1110 is about the normal distribution. The key to a normal distribution, again, it's a symmetric bell-shaped. It's centered at the mean, and that's when you want to use mean standard deviation. We talked a couple days ago about skewed data. You use the median IQR to talk about things. If it's not skewed or if it's normal, you want to use mean and standard deviation because it has way more meaning to it. And again, this is the key here. So between one standard deviation here is 68% of all my data. Between two standard deviations of a normal curve is 95% of your data. And between three standard deviations is 99.7% of all your data if it's considered a normal distribution or normal model. So in problem 1, the bar graph shows the weights of a population of female brown bears. The red curve shows how the weights are normally distributed about the mean, which is 115 kilograms. Now I always write down my mean, which is 115. Approximately what percent of female bears weigh between 100 and 129? So this is kind of nice. They kind of give you a graph here to look at. So if my mean is 115, that's right in the middle here, okay? How many bears weigh between this and this? Well, just look at the percentages. So that's what, approximately 23%, give or take. Plus, look at the middle bar. That middle bar is right about 42%. And because of symmetry, this bar is going to be exactly the same, that 23. Okay, add them up, and you end up with 88 total bears, or percent of bears, way between those. Problem 2 is about sketching the normal curve. Now, it says for a population of male European eels, the mean body length and one positive and negative standard deviation is shown below. Sketch a normal curve showing that the eel lengths at 1, 2, and 3 standard deviations from the mean. So again, it's pretty simple. You start off with your normal curve, and it's just going to be looking kind of like that. Okay, something along those lines. Now, your mean's in the middle. Call that right here. Let's mark that at 15.7. Okay, so one standard deviation positive is 18.5. So we'll mark that there. Well, one negative standard deviation is 12.9. So how far is it between those? Well, it's pretty simple. Just take 18.5 minus 15.7. And the distance here, one standard deviation, is 2.8. Okay, so how do I find the next bar? Well, I'm going to add another standard deviation, which means I'm going to add 2.8 again. So 18.5 plus 2.8 is 21.3. And 21.3 plus 2.8 again is 24.1. Okay, now same thing here. I would subtract these two, but because it's a normal model, you know that's going to be 2.8 again. Well, again, so how do I get to this one? Take 12.9 minus 2.8, 10.1. Subtract 2.8 again, that gives me 7.3. That gives me this is one standard deviation, this is two standard deviations, three standard deviations away. This is, again, my mean. This is -1, -2, and -3 standard deviations away. Example 3 is about the heights of adult American males, and it says they're approximately normally distributed with mean of 69.5 and a standard deviation is 2.5. I always go ahead and write that down. 69.5 with a standard deviation of 2.5. Okay, that's going to help me because, again, I'm going to use my calculator for this. Just like last chapter we used binomial models, this is a normal model. So your calculator has normal functions for this too. So this is the key here. Now you could draw a picture and a normal curve and everything else like that. It's not worth the effort because you have this thing called a normal. And again, for a normal model, you're always going to use CDF. So you're going to normal model CDF. Your lower bound, well, where does it start at? 67. So that's going to be your lower. Your upper is going to be 74.5. My mean, which they told me is 69.5. My standard deviation is 2.5. You'll see that in your menus when you go to put it. This is your lower. This is your upper. This is your mean. This is your standard deviation. Okay, so you plugged in your calculator. What percent of adult males are between those two measurements? About 81.9% of males. So you're looking at B. It says in a group of 2,000 adult American males, about how many would you expect to be taller than 72 inches? Well, again, it's a normal model, so we're gonna use that. Let's sketch it. We should always kind of sketch our graph when we have it. We know my mean is 69.5, right? We know my standard deviation is 2.5, correct? Well, where's 72 at in relation to that? It's right here. We want to know about how many would you expect to be taller than 72. So where's taller than 72? That's up here. That's what we want to know. We want the probability that x is greater than 72. Okay, so again, I'm going to use this normal CDF thing again, and I'm going to hit normal CDF, my calculator. Well, now, notice this. Notice how I shade above it? So my lower is 72. My upper, there is no upper. It doesn't end. So in order to represent that, I'm going to put 10 to the 10th. It doesn't really matter what that number is, but 10 to the 10th is going to be big enough to give me an accurate representation. Again, my mean still 69.5. My standard deviation still 2.5. Nothing changes there. So I plug that in. That's going to give me about 15.9, which is roughly 16%. But that's way more accurate than if we were just drawing pictures. So again, that's how you do that.